Hello guys, okay, today I'm gonna show some interview questions from TikTok. I use this website. I don't know if it's true, but just try it. Okay, and so I already saw on the hard problem, so now I'm gonna show some medium problem. Just today we're gonna take it easy to just to relax. This today is the weekend, so I want to relax a little bit. Okay, so I think we need to adjust this here. Wait a minute.
All right. Okay. All right. Okay. Now the first problem. House robber. You are a professional robber. Robber planning. Oh my God! To rob a house along a street. Oh my God! Each house has a certain amount of money stashed. What does stash mean? Okay. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected with. It will automatically contain the parts if two adjacent houses were broken into the same night. So, given the integer array nums represent the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police though. So basically, the problem is like you got a list of number represent the amount of money for of each house. So we can we can wrap to adjacent houses because of the security systems. Okay? And we will get the policy like that. And it turns out the problem turns out we need to select a sub array, I mean a subsequence on the original, and make sure that the selected element uh, is not there's no two elements in the selected selected set is adjacent. So it's I think it's a dynamic programming problem because we need to manage the state like we need for I we need to manage if the previous house is robbed or not. So let's say dpi zero mean like the we that's will be the optimal solution for subproblem nums 0 to I, and the and not rob the previous house. We didn't rob the I mean we don't rob the previous house. I say don't rob the previous house. I say not true. And this DPI1 is the same one, but we just the the robber rob the previous, so we can rob this house, this its house, this I house, just like that. Okay, so based on the we assume that we have an optimal subproblem, we can optimize the larger problem by using this formula like I1 I0 it must be that's mean the previous house isn't robbed, so we could rob this current house like let me see, actually we could rob the sorry we definitely want to rob this house, so it's something like this. And the previous house must not be robbed before, so it's 0, and we could add the current the second solution is we don't rob this house. That means the previous one could be robbed or not. Maybe this or this is okay. So we want to optimize, find the optimal solution, so just gonna need to max it. Oh, that's it. Okay. So this is the DP solution with ON. Let me say it's the exactly ON O2N, and actually it's the ON. In the time space is O2N. Okay, that's it. But let me think if we could okay, just start coding here. So gonna vector the vector in here the DP, let's say N, and here to on initially this 0, okay, from 0 to N. So the really first solution is dp0 is exactly equal to it will wrap it exactly equal to the number 0. We could dp from 1. dpi 0 here is the actual mass as dpi 0 minus 1 0 with dpi minus 1 1, and the second solution is must be like this. Okay, so the answer we need to find kind of the answers. Answer here, let's say initially is 0, the minimum 1. That means we don't store anything. So now we need to like max of everything. Answers masses dp0 and dp is 1, just to get math upon the possible solution. Run. Let's see. But slow. Yeah, I think we could optimize this more by. I think we don't need to use extra 0 1 here. By let me see, dpi is actually, let's say if we got I, we store it. We want to rob this house by default, so it must be like the previous house. We could store the previous house, right? And actually we could yeah, that's it. The second solution is don't store. Let me see. The better way is we store the previous one and don't rob the current house. But the problem is now we don't need to do so. Let's say dpi minus 1 could, that means dpi could be robbed or not. So if we get this, that means something that is a rob, and if not rob, that could be, if we not rob this ith house, that means we follow this condition. So I think this is okay. Yeah, say. We don't want to rob. The e-how could be robbed or not. For safety, they get I-2 is definitely safe, but the solution is safe too, right? Just get mass of them, and that means the ith house may not robbed yet. So it may refer to this case is normal. Okay, let's say we only need one dp. dp0 exactly, it could be 1 or actually we need to store this. dpi is actually not dpi minus 1. Let's say we don't want to store this house, and if I need to dpi massive dpi and dpi minus 2 plus 1i think this is the solution for this kind of problem. Say. Yeah, that's it. It's maybe two. I see. Uh-huh. You're right. The really easy way is it try to store this house. Initially, mm, we cannot do this. Else, TPI must TPI of TPI names I. That's this. Yeah, 100%. But let's say how people talk about this problem, like kind of to explain in the to explain in a what kind of easy. Oh, only 01. Right. Oh, we're right. We need to start the previous one and the previous the two previous ones, so we don't need to start a whole array. This is the right solution. How could we talk about this? Okay, graph current house. Don't graph current house. Yeah, we only have two option. When option A is selected, that means we can route previous -1 house, but can safely proceed to the one before. Exactly. The option we choose, we select the rubber gas on the possible load from the robbery of -1 on the product buildings. Right. That is the formula. We could redo this using a for loop like this. Really simple. And actually we could optimize this more by we don't need to store the previous let's say the previous one is 0 and the kind of the previous of the previous, let's say previous 2 example, and actually the previous is definitely nums 0, let's say. We want to optimize this previous, like the current, let's say current like master's previous one. That means we don't swap this house and the previous 2 plus the current one. That means we want to route this house and the previous 2 gonna become previous and the previous now become current. And we always want to maximize our answer. Just get the maximize answer recurring. Make sure, let's say this, so that's my solution if we don't want to use extra space. Yeah, definitely. Okay, it's right. I say just really right. Oh, the previous one is always the mass solution. I think that's right, because we could definitely say that the more we go, the more money we grab. So it's always better to return the current answer, right? Well, I don't know why this it's not got this next problem. Ooh. Okay, this generates parentheses is kind of good problem too. We can solve it. This one is really funny, I guess. So I'm gonna solve this backtracking problem first. Generate on combinations of well-formed parentheses This is kind of easy. When you open, you need to close. We have it's like we need to maintain if we open. We need to maintain when we open, we need to close. So we need to maintain the number of opened unmatched open character here. If we close, the count must be -1, and if we open new, that means the count must be +1. So the problem is we don't want to close more than open. So if the count is gonna like reduce to less than 0, that's invalid. But at the end, if it is I have to create the parenthesis of length to n. Let's say check web parenthesis. I think there's a more harder problem. This like general parenthesis with the depths. It's kind of harder. This is really easy. Okay. So let's try to write the code. Answer. Say void string. Want to create a string, and for sure we need to maintain the count as integer, and we also need to determine if we reach the current length. Okay, this is in a parameter. Let's say backtrack here, capture everything. Let's say this string, the current string, and like the count. Let's say the count. If the curve size is actually 2n, given n parentheses, the length must be 2n. That's definitely true. The another thing is we need to open only n times. So I think we could use a number like num open here to better manage the number of current open I say open parentheses. Let's say it reached the end. So actually this is a solution for us. Remember, and at this point we need to open. We could open or close. If the open is still larger than 0, we could open it by backtrack current plus open it. That is, the count must be +1. The num open gonna be reduced by 1. Else there's nothing to open. Sorry. There's another way. It's like if the count is less than 0, that means we could add one more close plus count -1, but still the same. And I think this is the solution. Backtrack, empty string, the count 0, and open the end. That's it. Right. Oh, right. Okay, back to the backtrack. Dynamic programming. I hope it good today we saw 10 problem, but we only saw 3. Add 2. Next one. Given an integer array nums, find the subarray with the largest sum. Return the sum. The subarray with the largest sum. Subarray means a contiguous non-empty sequence of elements within an array. Okay, this means we got the segment, a window. Say was it could be 4 minus 1 to 1. This is actually the largest. Why not this smaller? Okay. Let me see. You have figured out this LN solution. Try coding another solution using deeper and conquer approach, which is more subtle. Funny, but let's try to solve this with ON solution first. Okay. Okay, let's say we got a segment. Let's say we let define a sum. and also how to get the sum of a sub-array fast. Like we could define the prefix sum, like sum I is actually the sum of the nums 1 plus num1 give to nums I. So basically we could calculate the sum of from left to right by get the sum of I here and the sum of n minus 1. That can be easily proved by writing it down. If you want me to prove it, to prove this. Do you want me to prove this? Actually, it's really easy. Just num 0 to nums r and minus let's say nums minus 1 0 to nums l minus 1. Yeah, definitely the L is let's say L is less than R, less than equal to R. So that's mean we remaining we got nums R minus 1 and 2 nums L, and that's definitely what we want. So basically, what could we have based on this? Let's say actually we got this, like if we ask a point at position R, we want to maximize some L minus some L minus 1, and you can see that we want to maximize this, we need to find smallest some L minus 1. Easy. How to that's easy. Just store the minimum value from the left side. Really easy. So so okay, now just do it. Size, let's store something like min sum initially 0 and the custom initially 0 to custom plus let me say nums I, and we really want to get the answers. Initially it must be remember this is some empty number, so let's say it's actually equal to num 0. This is one of the possible solution, and definitely it could be greater. So if custom let's say answers like try to maximize let the custom minus the min sum, that's it. And the min sum we need to update the current min sum on the left side. Now we move to the next, so we need to update the current position. That's mean the min sum and the custom. Why we got 0 here? Because we said we could define that the sum, the very beginning, the initial case of sum is equal to 0. Let's say it's something like that. Because if we want to calculate sum from 1 to R, we actually want to calculate the sum R minus sum 0 minus 1, and there is no sum 0 minus 1, and definitely it must equal to sum R, and let's say sum is actually equal to 0. Okay. So that is a solution. Definitely. Oh, slow. Okay, this is one of the possible solution. Another way is I could think about is like just sum it, just add it, because if it's the positive value, just add it, but then it's maybe go down to 0. Let's say the second grade. This is the approach 1. Approach 2. Let's say the current sum is kind of sum of from left to I, which I is the current position, and else is somewhere less than the R, less than or equal to the R here. And if the sum of R is like less than 0, just continue, but then expand it. And if something like let's say less than 0, that means we would cut off we need to cut off this sum because it just negatively affect our result. But how to cut off this? You could definitely shrink left. Yes, may become some of -1 to R. Somehow is not better, like but when we reach the -1 here, that's mean for example if we from the, let's say sum from L -1 is less than 0 and we go to sum L right, and but definitely it's become less than 0. That's mean the nums L is really negative. Let's say negative, really, really small number. So we don't want to add this number to because it affect the whole period sum. So that means we need to ignore it, and the norming here is skip to R. That is so my soon gonna become like the curse sum here 0, and we need to store the answer somewhere, I don't know, somewhere like num 0. Let's say if curse sum plus the nums I, and let's say answer plus answer, sorry, answer of the curse sum. And if the curse sum is definitely less than 0, just reset it. That's another solution approach to, and it works. Do you want it's not too fast here? Okay, but it's good enough for me. Now you want to do divide and conquer approach. Remember my previous solution? This is in the Bible. Like, remember my previous solution? Oh my god, I already saw this before. Oh my god. Oh really? Funny how I saw this before, and yo god, can't believe I saw it before. Okay, but now we'll think about the divide conquer solution. So let me open the pivot solution. That is, we need to find the mean on the left side and the current max value, the current value. So if we divide and conquer, this is really easy. Like, let me see, approach to 3. Let's say we got the left subarray, like left array and the right array, and we could maximize sum by select the mass of the right array, the mass sum, or the right array minus the mean sum of the left array. And that is how it works to maximize all. Alright, I could see. Great. So okay, the solution gonna divide the original array into two further left array and right array. Let's say left array is like from the let's say from the left to the mid, and the right array is somewhere like mid +1 to the side -1 side here, the array. That's it. And basically we want to calculate the sum of every position on that. And we also want to calculate the sum, but the sum, let's say sum I here is actually the array right. Alright, to array I, say the sum here. How do we calculate sum from two different parts? That kind of so let's just say sum I is actually equal to array mid +1 to array I, and how to get the sum of from the left to right here is definitely okay. Let's say Just ignore this. Uh, Actually sum of 2 the make here plus the sum of make plus 1 here to the r. So why don't we revert this kind of something like array I plus into array I here, array make here. It's kind of easier to, so we want to mask minus, right? That means we got the mask on the left side and the mask of the right side plus this. Oh, so we gotta calculate the max suffix, calculate max prefix. Okay, that's the solution. Okay, gonna write the function define conquer here. Let's say the function gonna return the max of a range from left to right, and okay, that's it. Let's say it's like divide something like this, left, right. Okay, if let's say L equal to right, that means only one element, just return it. That's it. How about if there are 2 elements? That's not problem. So we need to divide the left side. Left plus right divide by 2. Divide, and we want to calculate the suffix of the right. Okay, let me see. So kind of arrange here. We want to get how to know if it's a left or right. It's kind of crazy, so we need to pass like both side it left, like that. Okay. So we really want to return the max the defined. Let's say we got the max left to kind of define true. Right, let's say define and plus 1 right true. But this solution is, I don't like it too much. This is really more subtle. I don't think so, but just try to code it. Okay. Made true. Okay. This must be false. Let's say we got the max left, we got the max right, and we're going to combine it. This is a subsegment, but actually recursively it not affect the parent. We need to still need to store the max left side or max the right side. Crazy problem. How to do this better? I just don't know. Let me see how to do this in ON. Is that is not ON? You need to divide and divide. No, it's not ON and log n. Just I don't know how. Let me see. So you really want to? I actually must have it on minute max. Oh hell! How we solve it with don't want to waste too much time, so I really want to see the divide and conquer solution here. I really don't know how to use divide and conquer. This is really a solution like that. This is definitely what I say. That's definitely what I said here. By oh, you ignore the current element. But this solution is, and it's not too fast. I think it's really slow. Can't believe why you will want to use Divine Conqueror to do so. This kind of problem. It's unlock for sure. Just to see the editorial, I really don't like the Divine Conqueror solution. It's take up to and lock. It's not definitely it's not O N, but the code is not better. For sure, it's not better. Yeah, you divide it and you just find the left some. So could we just ignore this? Kinda, I really don't like the divine conquer solution there. But is it require me to do that? I gonna just do like this guy do. Just try all the possible divide it by two, and just for the left side just get the max. For the right side just to get the max, and we get the max, the sum of that. Here you can see get the sum of this, and don't forget to, because don't forget to return the max left right. Why we need to do this? The max left right is a kind of thing like we need to sum it from the middle to the left. Let's say max left right. What is a max left right? Max where? Somewhere in the middle, right? And we still need to add the segment. Okay, it's very funny, but we don't need to waste too much time on this. Okay, so can we move on to the next problem? Right. Kind change. Let's say you're given an integer array coins represent coins of different denominations. An integer different denomination. What the hell is okay, all right. Denominations an integer amount representing a total amount of money within the fewest number. Okay, it's really really basic dynamic problem. But here's the trick. Whenever I receive the problem, I got to ask that, could you tell me like the size of the coins and the value of each coin and the amount here? And they're gonna say something like that is really small. With this small, we sorry, like even the words of each category. Funny. So we can't use backtracking because we don't know how much to use. Problem is they're gonna give the cost value is really large here, and definitely we don't need them because the add only increase the amount. We just skip on the value that's larger than the amount here and bring this coin size back to 10 power 4. Yeah. So talking about the solution of this is just like knapsack problem like DP, and with the sum, let's say sum chase like the from the let me say from the to like coins the fewest, say the fewest number of coins need to make up J. So really easy. It's like we see if we could optimize the problem using sub problem. Let's say we could to come we will need to determine which state that's transformed to this problem, this state. Let's say from the previous one, I-1 coins, if we could create this sum, so that means we don't need to add more to make the sum j, right? Another thing is we need to add this coin -1, and we could add exactly a number like the coins are here. The problem is that we could add more. So let's say just UI. Why? Because we could transform to the new state using this, and then we got the coin I. That's it. So to calculate this goods, we could say that you could say that the larger trace depends on let's say smaller tray. Let's say with this less than j. So we could use a backward for backward 4. You can say backward 4. So okay, now just code it vector. Oh, it depends on the previous one and the new one, so we're gonna create a 2D vector dp. Sorry, amount. This is definitely quite size, and the let's say amount +1 on 0. On 0 because okay, we want to fuel it. Okay, all right. Now try form. Try each coin. Try each amount value. DPI chase definitely is equal to DPI -1, which we don't need this coin, which we transform from the previous coin to the new coin. And the problem, let's say DPI chase is really large number. The best way, a real large number, let's say define if m less than 1, just so we can use this. If trace sorry, we need to fall down this if trace minus that's num I is kind of less than 0, so we could add it. DPI trace like mean, yeah, right, mean I trace num I +1. Need one more coin for this, and the final solution must be dp with the coin size -1, using the entire set of coins and create the amount. That's it. What? Just, oh my god, I would. No, the initial case is, let's say the really initial case is dp00 is actually equal to, what? 0. That's right, I think this is right. my god, why I do this? Sorry, just a moment. What? Oh my god, what happened? It must be true. Let me check it out. Hmm. What happened? I let's say no, I think it's correct, but v so -1, I'll just return that value. That's it. Really slow. Memory cost, we don't need to store the 2D array, for sure. I also want to make it a constant. Stay constant. Say real large number, some large number. You see, you don't need to do so because it will depends. HTTP tree will depends on the real previous state. The previous state actually the I-1 here. All the trace minus count here. That's mean let's say here is h depends on smaller trace. So we could do something like. Can we do it? Let me say. And it's also dpij. Let's say dpij depends on -1, which is the same tray. And actually, when we for love fit the dpi is have the, let me see if we streamline to stay into one dimension. The dpj is actually alphabet ignore the I state. And we actually we at this moment we got the dpi-1, the old j, and we only need to get this value and not affect on the other dpi-j. That means we could fall down from the large value to the I see it's not affect its other. Sorry. DPJ is not affect. If not, DPI. I say DPJ is its solution, and it's gonna depends on DDO -1 and the PI and J coins I. So if we only use J, actually if we've done the previous 4 amount value here, we actually got the dpi-j, and we could pass it to the dpj. But the problem is this: we don't want to affect dpj for the j's one. For this, we don't really want to change this value because this is gonna depends on the previous one. So appropriate solution here. Yeah. depends on the previous, and we don't want to affect the current. Yeah, so really simple. Just one size enough. TP amount. That's right on repeat. Definitely PC was. Let's say that. It's still ON power 2, but space efficient. Let's say dpj gonna be count max means dpj with dpj minus nums I. dpj minus num I. Sorry, coins I dpj is dpj with dpj as coins I as one capacity. If dp amount is larger than infinity, so return minus 1 and we'll return dp amount. That's it. Enough. We don't want to store the whole array because we only depend on the previous one static counts. Only depends on the previous and the current row. Oh, what do you mean? What happened? Undefined solution infinity. What happened with you? Oh, what the hell? You want me to write like this? Crazy. I talk too much. Come on, let's go. Let's see the top one solution. Oh, DP, top down method. Right. Oh, it's using that. Oh, but it's like a trick. I don't believe it. This like, wow, Camel is really simple. The if is that there's no if condition. Alright, so all we need to do is for to the mile minus coins I and don't want to check for this value and it's still correct. Sorry. There we need to follow from count A to amount. Don't need to check. No, it's wrong. It's gonna be wrong. Oh my god, it's still true. And I think it's gonna be wrong because we ignore some tray. Oh my god, it's still correct. Okay. It's enough for today. Maximum product subarray. Got it. I need to wash my face. Go. Given an integer array nums, find a subarray. Let me see. Previously we got a problem like what's that? The maximum subarray using divide conquer. There actually a problem like that on the use second tree mass. Let's say that math subarray. So yeah, subarray is a given range. This is really a really famous symmetry problem using divide conquer to find the maximum subarray in the range, and it's ideal. Let me tell you a little bit about this. got like four way to assume that we got two segments and this sum. We got a, we got four way to conduct this sum, the middle sum. The first one is try to maximum the previous sum. The previous sum matters and we append it with any element here is okay. Let's say to construct the maximum previous sum using left and the right try. Here's the right try and the mass previous sum is, let's say 3, and you could append anything here. That's we've got a statement here and we append it, we connect it to the mix. The second solution we use the 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 suffix and with some value here before, with some on the left side as I say here. The maximum prefix sum contains every array element on the left try. Yeah, and we need to add some right try. The second way is actually total sum of left try plus the maximum prefix sum of right try. Really? Okay, that's the second way. Is the third way is like consider the maximum suffix sum. Use left and right. You could like try to get the max on the left and the max on the right and concat it. It's not, we don't need to make it contain the whole prefix or the whole and as we describe here. Here it's somewhere in the middle. Here and it's like maximum suffix sum of right try and plus the maximum sum on the left side. What? Crazy is gonna use yeah, this is actually what gonna do, but is you see O and lock, you see sub array sum. This is kind of really famous problem where I learned about segment tree. That's, I just want to record a little bit. Maybe it's gonna happen in the interview. Says points. I already have a I already saw this problem before. Here, max value among prefix sum of this node. Find M. You can see a total sum. The mass pivot sum. Yeah, actually get the master pivot sum is left try master pivot sum. Or you use the whole sum plus the master. Yeah, that's definitely what we use to build the segment tree. But I don't know if we could use it in the maximum array problem here. Because this, as you reach the solution using divine conquer is really silly. I don't know why they suggest a kind of solution. Here, like, let's read this out. It's gonna find the max of left and the max of right, and we could figure out just get the sum on the left side and append the max of right and concat it. We need to include the current element for sure. And the second way is you just choose one or two. That's it. That's it. Okay, that's it. get the max of the left try, the right try, and the subsegment. That is the solution, but I don't like it. Okay, snap. So we're gonna move to the next problem. Maximum product separate. Let's see if today we go. So how many problem today? One, two. Okay. 1, 2, 3, 4. This is the 5. This is the fifth problem. Yeah, say that check. Okay, go. The largest product. Wait. Well, the part of any array of numbers equal to the fifth. Oh, really funny. We don't need to check it. Okay. There's something we need to consider. First of all, we need to ask if there's a negative number. Actually, there's a negative number. It was add like it is the size array is empty, so we should return which value is actually no empty. And okay, so think about social result. Have some observation. The first one is kind of let's say the even negative numbers. Let's say even number of negative numbers. Value. Let's say values gonna produce a positive product. That's it. 2. Subarray contain 0, produce a 0 product. The second thing, we will want to skip this negative number. We want to maximize this. So as if there's only a positive number, we only need to extend the size of the window, like, because the more we have, the higher product, the largest product. But that's less a negative number. But it would be nice if we have to an even number of negative values. So it's gonna produce, as I said, it's gonna produce a positive sum. So based on this observation, we need to care about the 0 and the negative number. Let's say we got the segment from left to right here. If the count negative number from left to right mod to equal to 0, so we can conduct a positive product. So we just get the product of based on value which in numbers left to right on h in left to right, and we at large the arrays is better. But the problem is count 0 here in the left right is less than 1, so we're gonna return 0. We don't want to keep this array. We don't want to have the 0 in the array. So the original array num is gonna divide it into subarray selected by 0 value, by 0 values, and let's say let's say kind of if we ask a position and we know the previous 0 position, that is previous 0 must be less than r. Okay, is it e0, so we just ignore it, and that's mean from previous 0 plus 1 to r, we really want to, if the count, we really want to find a position. Let's say it L subtract that from the previous 0 plus 1, actually like this, and the count negative from left to write asterisk like this. Mm. Crazy, huh? But how we could find this? Oh, I talk too much and I feel so, so exotic. Um, so I really want to. This it really depends on the parity. Kind of something like if the cow, if we got a cow neck. I see actually the cow on negative numbers from 0 to R. Oh, see, from 0 to R. Sorry. Let's say we're gonna reset the lesson from the previous 0 plus 1. Okay, previously what 0 0. Okay, because previous 0 is actually 0. We count on this. So to if cow neck R is 0, so that means cow neck L minus 1 must be 0. If cow neck R is 1, so cow neck R minus 1 must be 1. That's have the same parity. Must have the same parity. What is parity here? Parity mean 1 1 0 0. Yeah. Bit parity, like that. Okay. So we want to maximize this. Okay. We want to store the first position that have this and the first positions that have this, and based on that we could retrieve the errors really fast and get the product really fast. uh, but how could we get the product really fast as we mm, mm. Because if we extend the array and the largest is the larger the size, the larger the value. Just let me take a rest. I feel so tired now. I think this is my last problem. It's 5 problems. I talk too much. And maybe the next 5 problems I just keep silent. Yeah, so we need to keep the first position of this and the last position of this. So after that, just calculate the product easily, right? So now let's solve it. Yeah, this is the abstract. We don't need to actually store it. We need to store the thing like pause and like the mass pause to store this kind of value. Okay, initially it should be something really large. Really large. Let's say so it's maybe unsigned. So I think use long is better because unsigned could be exit the this is what be the really small answer. Here you see the mass element of the basic answer, the mass element, max. the mean pause here is kind of something really large. Let's say, just let's say somewhere like this. Yeah, it's really small like this. We don't really need to for to end. Okay, let's check if the numbers are actually zero. We need to start the new things as pause. Zero, let me pause one. I kind of and mass pause one, mass pause. What is it? Zero minus one. Else, if num I is less than zero, we need to mean pause. Let's say the count. Remember to count negative. Count negative zero. Count negative connect. Just we just need to store the parity of this. We don't need to store the exact value. So kind of mean pause of connect mean that mean pause of connect with this position. This is the position I and the last pause. We could do this better, but this is for simplification. Max pause, yeah. And we will meet a zero. That means we got a new segment, so we need to calculate the previous one. So actually, it must be answers for the straight from the I think from the just check on the T from 0 to for trade from pause of T to last pause of T and the product here, the product multiplied by num trade. I really want to mask the answer with this product. That's right, very easy. Yeah, for the numbers less than zero, we don't need to care about it. But actually, there's another egg case. We don't want for the last element. Actually, the last segment. Just do something like this. This much better. Okay, return the answer. Four. It can be four. Okay, it's okay. Can negative. Initially is zero, sure. I say, like zero here. When we met this zero, 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 one, one. So this, sorry, it must be from somewhere plus one. That T, sorry, is kind of T plus one. Okay, for example, this with this, the parity gonna be something like this. So we say 0, 0, 1, 1, and you really like this one. This is one. You need to really write this segment. And for the zero, it must be this segment. But yeah, it's minus one, sure. Yeah. Okay. For the initial, in the case, there's no negative, so the count zero must be somewhere like zero. Let's see. Yeah, it is obviously. Yeah, it's really obviously. Yeah. Wherever we reset it, remember remember one thing: the mean positive zero as positive zero is always be the current element. The mean positive one and is somewhere realized I will assign this number, and the mass positive one is I want to mathematics, so somewhere this. We're tired now. I don't know what's wrong. Let me see. You really want to. Okay, when you reach the end, let's say this. Do you want to find the one and the mean pos zero is actually minus one for sure. I want to count it out. Okay, I just see that. Now there's always a zero somewhere. Otherwise it's will return minus one. First, minus one. Two, no. Oh God, this must be true. So let's check. If still minus point, we continue. That's it. That's what I'm looking for. What you doing? TP? Nah. I used to pointer, man. Oh, this much better. Oh my God. Wow. Hey, this solution is amazing. Wow. Oh my God, this is crazy. This resolution is crazy. Great, really great. So this is kind of like when we miss something less than zero. So if we multiply, it's gonna swap the min and the max. So all we need to do is just try to maximize it. Oh my gosh, this solution is great. But in my solution is okay. So we're gonna move to the next problem. Oh, see the today's longer increasing. This I think I already finished this problem. Okay, you could watch my previous video. So I got a massive true pattern from string. I already saw this before, so you could watch my previous 7. Let me see. Okay, rock break. Let me kiss the episode before now. Okay, great to see. Given a string S and a dictionary of strings for dict, it intuits that can be segmented into space separate sequence of one or more dictionary words. The same word in the dictionary may be reused multiple times. Basic DP solution. Okay, just what today is good to me. We meet you then. Bye.